This last section in Chapter 2, solving inequalities in one variable, we're going to look at the two types of functions and/or equations that we've dealt with in this chapter, those being polynomial and rational, and how to solve their inequalities. This first one is titled Solving a Polynomial Inequality Algebraically. Solving it algebraically, the first thing I'm going to try and do is find its zeros. And to find its zeros, I'm going to try and factor it. Now, I'm lucky here, being this is 4 terms, it does factor by grouping. I can take an x, how about this? An x squared out of the first 2, leaving me 2x minus 7. And I can take out a, let's see. Well, I'll back up. This does not factor by grouping. If I were to take out a common factor of these two, which would be a -2, that leaves 5x minus 12. That's not the same as this one here. So this actually does not factor by grouping. Okay, so I tried, it didn't work. So let's see, how could we then factor this? Well, since it doesn't factor by grouping, what I'm going to look for is a way to begin the factoring process, and that would be what we did in sections 2.4 and 2.5, where I list out all the possible rational zeros and then divide them out with synthetic division. Now, instead of listing out all the possible zeros, what I'm going to do is just go ahead and graph it and see if I can find a zero that way. So 2x to the third minus 7x squared minus 10x plus 24. I know it says solve it algebraically. I'm just going to use the calculator to help out, but I'm going to use algebra here on paper. So it looks like it crosses through the x-axis at -2. So let's try to divide out -2. Okay, so I bring down the 2 and I multiply, I add and I multiply, I add and I multiply, and sure enough it does. Now it also looks like it crosses at 4, so I'm going to try 4. So I bring down the 2 and I multiply, I add and I multiply, and that works as well. And if I solve what's left, this is 2x minus 3 equals 0. The other one would be 3/2. Okay. So let me rewrite this problem in a factored form. Okay. So this problem, now that I've got the zeros, is x plus 2 times x minus 4 times 2x minus 3 is greater than 0. So my zeros -2, 4, and 3/2. Okay, so solving this algebraically, well, there's 2 ways that I could do this maybe. I'd like to show you both. If I can fit them both on this piece of paper, I'll show you both here. Let me fit the first one down here. I'm going to solve, algebraically. I've done the algebra here. I've found the zeros, but I'm going to utilize a graph to kind of help me out. So I want to tie this to some information that we've already studied this chapter, and this will be a good way to do it. This function has 3 zeros. All right, so we go -2, 3/2, and 4. It's odd and positive, which means that it's going to have in behavior of down on the left, let's scoot this up a little bit, down on the left and up on the right. So knowing the zeros where I cross, I could fill in something like this, this, and then right through here, ending going up. Okay, that's kind of what this graph would look like. Now I want to know where this graph is greater than 0. Greater than 0 means where is it above y equals 0? Where is it above the x-axis? Well, it's above the x-axis between these points and out here. So it's above the x-axis from -2 to the 3/2 and 4 to infinity. Okay, so that's one way to do it. It's one way to finish the problem once we have the zeros found, is I can take those zeros and my knowledge of what polynomial graphs look like, and I can solve the problem pretty simple. The other way to do it, so say I have no knowledge of the graphs, or you've forgotten everything I've taught you about the graphs already. What I can do is I can take these zeros, I'm going to do a number line analysis. I've got -2 as an answer, I've got 3/2 as an answer, I've got 4 as an answer. I'm using open circles everywhere because there is no equal to on the inequality. And what we're going to do is pick numbers. Okay, so let's just pick something out here. If I pick -3 and I plug it in for all of these x's, okay, what happens is the first parenthesis is negative, the second parenthesis is negative, and the last parenthesis is negative. Three negatives multiply to be negative, and negative numbers are not greater than 0, so that doesn't work. Now I pick something between -2 and 3/2, that could be 0. And I plug them into all the x's. 0 plus 2 is positive, 0 minus 4 is negative, and 0 minus 3 is negative. Two negatives make a positive. I want positive things because positive things are greater than 0, so I shade right there. And you can see how that shaded area is this, which is also this area here. So I can continue like this and just pick numbers between these spots, plug them in, and see if it makes the inequality true. So there you go. There's the algebraic approach with a graphical and number line analysis, kind of two ways to finish out that problem. Neither is more correct than the other. They both work just fine. Directions here say solve a polynomial inequality graphically. Okay, so graphically, first thing I'm going to do is make it all the terms on one side. So let's say plus 8x minus 2 is less than or equal to 0. I look over this, it's got 4 terms, it doesn't factor by grouping. So let's take a graphical approach to this. So I'm going to type this in. And I think the problem with this is that all the places it's going to cross the x-axis quite possibly are not rational values. They're not going to come from that rational zeros theorem. I'm not going to be able to, I'm looking here and there's no integer value. There's no easy number to divide by like there was in the last problem. Let me even zoom in on this so you can see it a little bit better. Okay, so I'm looking at where does it cross the x-axis. And that's kind of close to a half, but maybe it's not. It's kind of close to 1.5, but maybe it's not. And this one's a little bigger than 4, so I don't really have good solutions, good numbers. So what I'm going to do is just kind of purely a graphical slash number line analysis, I guess. It crosses 3 times. Let's find them all by calculating the zeros. Okay, so I'm going to find the one on the left first. We've done this before, so I'm not reteaching it, I'm just doing it. So this first one is 0.32. Second one is 1.46. And the third one. Third one is 4.21. Okay, so there are my zeros. They were irrational values. I couldn't find them by factoring or doing the synthetic division. I had to do them this way. Alright, so on each of these we're going to have closed circles because there is an equal to. And I'm just going to maybe superimpose what a graph on this would look like. It's positive odd power, so that means it's got to come up here, then down, then back up. So its graph kind of looks like this. I want everywhere where the graph is less than 0, it's below the x-axis. So it's below the x-axis out here and between these numbers right here. So it's going to be negative infinity to 0.32 square bracket and 1.46 to 4.21 square brackets on that too. Okay, so there is kind of a purely graphical approach to solving this problem. We had to find the zeros with the graph, and we had to, or I just used the graphical approach, knowing what the shape of the graph would look like to solve this problem for me.